So good afternoon. So whenever you receive this question, the easiest way is obviously to square both sides. So it'll be, just write it in white. So it'll be 5x plus 7 squared greater than 2x minus 3 squared. So from here onwards, what you're going to do, you're going to expand those things. I just try to find my calculator right now. So whenever I need it, I don't need to go grab it somewhere. But I can do this one in my head quickly. So that's 25x squared. And that would be 2 times 7, which is 14 times 5 times 10, it's 50. So then times plus 4, which is 20, that's 70. Okay, x. And then it will be my plus 49. And then this is greater than 4x squared minus 6 times 2, that's 12x, and it's plus 9. So then we start minusing, adding. So with that, you need to, I actually don't know where my calculator is. This is bad news because I'm gonna need it. I'm gonna need it. Yeah. Okay. So, let me just do this. So now when you get here, becomes this expression. Then after that, you just basically make it a quadratic equation. So it'll be 21 x squared. And then this will be this one minus that one. So that'll be plus. So that'll be 82. So that's plus 82x. This one minus that one. So that'll be plus 40. And then this will be greater than 0. So then you basically now use the quadratic formula to get your final answer. So the answer you will get from this, it will be x is less than negative 10 over 3. And then x is less than or greater than negative 4 over 7. So that's what you get from there. And now you move on to this one. So this is the one most of you lost marks in. So for this one, you introduce, since there's e there, you introduce ln on both sides. So there's e 6 to the power of 2x minus 1. And then it will be equates to ln of 5 e to the power of 3x plus 2. So then you have that. And then here you have to say ln of 5 plus ln of e to the power of 3x plus 2. So this is where most of you got it. Okay, the two of you got it wrong at this stage. And then you actually you left ln of 5e together and you put the 3x plus 2 to the front. So then this is, we can just drop this one down. So that would be 2x minus 1, ln of 6. And this will be ln of 5 plus 3x plus 2 ln of e, which happens to be 1. Then that whole part will fall away. So now you will have to just basically expand this one. So that's 2 ln of 6, and this will be that x, and then it will be minus ln of 6, and this will give you ln of 5 plus 3x plus 2. And now you have this part and that part. So you take everything that doesn't have x to that side, and everything that has x goes to that side. So now I'm just going to copy and paste. I'm going to leave this place blank because it's going to look like the top part. But now what I'm going to do, I'm going to just swap that, move that thing and move that ln of 6x to that side. So ln of 6 plus ln of 5 plus 2. And then in this you have 2 ln of 6, open bracket x, and then this will be minus 3x. Now with this, you take x out as a common factor, so you have 2 ln of 6, and then it's minus 3 equates to ln of 6 plus ln of 5 plus 2. With that, and then you divide both sides by that, so you have x equates to ln of 6 plus ln of 5 plus 2 divided by 2 ln of 6 minus 3. And now with this, you get an answer of 4 significant figures, which they ask you to do so. So that's 9.256. So that will be your final answer for this. So they did ask you to leave it in 4 significant figures. Just play the video slow if you don't understand it. And then for this one, they ask you to find the gradient. So with the gradient here, you need to find, you need basically to differentiate the following equation. So it's 8 e to the power of negative x minus e to the power of just 2 here, 2x. So just remember, when you have e to the power of negative something or e to the power of x, you just basically, it will be the following. So if you have e to the power of kx, the derivative of the following is the derivative of the top, which is k in this case, times kx, the original. So with this part, we just apply the same thing. The answer you get is negative e to the power of negative x. And then this will be minus 2 e to the power of 2x. And now this will be labeled a dy over dx. Now, they tell you all of this and they say find the gradient of the curve at point A. And we know at point A, if you're looking at this curve, this is where is the x-intercept. So we know that x equals to, it's the y-intercept, sorry, x equals to 0 then. So we'll basically say, okay, x equals to 0. And now we substitute 0 in there. So this, remember, gives you the gradient at any point of this curve. Now, you just have to substitute the x value, then you get the gradient. So dy over dx equates to negative 8 e to the power of negative 0. Let's put it in bracket, negative 2 e to the power of 2 and 0. Now, note that this negative 8 and that part will turn into 1. And then it's minus 2 turn into 1. And the answer you get there is negative 10. Okay, so that will be your dy over dx. So then if you obtain that, then you got your all of the 3 marks there. So yeah, you would have received 1 mark for this part. And then you would have received another mark for this part. And this part, let's say it's half mark there, half mark. And then the other mark is to obtain the correct expression, obviously, the full expression. Okay, let's move on quickly. Now they say, show that the ln of x, the x coordinate of B is ln 2, and hence find the area of the shaded region. So this is 5 marks, so it is a 2-part. The first part, we need to find the x coordinate of B. So then the x-coordinate of B, if we're looking at this diagram, the x-coordinate of B, it is the x-intercept, right? So x-intercept is where y is 0. So if you say y equates to 8 e to the power of negative x minus 2, not 2, sorry, e to the power of 2x. I think that was the equation, okay? Now, we know that y equates to 0 here. Now, we need to solve this equation. So say y equates to 0, 8, that e to the power of 2x. Now, with this part, we just take e to the power of this part, that side, because it's negative. So e to the power of 2x, and then we have 8 e to the power of negative x. Now I'm going to divide both sides by what? By this part. You can do it in other ways, but I prefer this way. So now you're going to have here, I want to explain this part because it's a little bit confusing. So you're going to have e to the power of, just focus on the exponent, 2x minus x. Now, with this case, and then here, obviously this one cancels that one, you have 8. So then you're going to have e to the power of 3x equals to 8. Now, obviously, if you take, what do you call it? Ln of both sides to make x a subject, so it'll be ln of e to the power of 3x equals to ln of 8, and then you have this one will be written as ln of 2 to the power of 3, and this will be 3x, because the ln of ex, if you drop it down, it will just fall away, and then you have this 3 going to the front, ln of 2, 3x, and then x becomes ln of 2 if you divide by 3 on both sides, because this 3 will cancel that one. So that's the coordinate of B. That is the first part. Now the second part is to deal with the area. Now the area of this shape, it will be, remember, it will be bound between what? This part and that part. So that will be 0 and ln of 2. So we go back to the original curve. So we say, okay, the area of B, it will be given by the integral of ln of 2 and 0 of 8 e to the power of negative x minus e to the power of 2x dx. Now, remember, instead of you dropping the derivative to the front or multiplying by it in integration, you divide it when you're dealing with exponential functions. So the area, it will be given by negative that one divided by -1, so it still gives you negative 8 e to the power of negative x. However, this one will give you negative 1 over 2 e to the power of 2x. So that's the only difference here with the integration and differentiation. So, okay, now we have that part. Now we say, okay, negative 8 e to the power of negative ln of 2 minus half e to the power of 2 ln of 2 minus, some people assume that this part becomes 0. It doesn't, people. It doesn't. You can't just assume like that, especially with exponential functions. It doesn't really work like that. Then we have e to the power of 0, which this part only turns into 1, and negative half. But essentially, this will be 1, because I can just put it as e to the power of 0 as well. So it will be 1. Okay, and now from here onwards, it is a equates to this part. What you can do is that you can put this negative up there, so it becomes -1. So you will have, let me just explain this part. So e to the power of ln of 2, -1. That negative, you can put it as -1 there. So basically, this part will cancel that ln. You have just e to the power of -1, which is a half. So basically, this whole part becomes a half. So you end up with what? -4. So negative 4. So this whole part turns into a half. Reason being, you're using this fact. Okay. Now, if you go, which is -1/2, and then this part as well, this 2 will go to the top there. It becomes 2 to the power of 2, and then it becomes just 2 to the power of 2. That's what it becomes, because this one cancels that ln. So it will become 4. And then we say minus, let's say plus 8 plus a half. Okay, now a becomes what? This one plus that one, that will be 2. So it will be -4 minus 2 plus 8 plus a half. Now, with that part, we basically do the following. So it will be minus 6 plus 8 plus a half. So that will be 2.5. The area is 5 over 2. Sorry, I don't have a calculator, so that's why I'm stretching it too far. Okay, now this one is quite easy. It's easy 7 marks of your life. They say now you have a parametric equation in terms of t, obviously, and now you just need to the boundaries between them. Find the equation of the normal. So remember, if you have m1, which is you find by the derivative, you must say it's 1 over, let's say m2, sorry, it will be m2, it will be 1 over m1, which is negative. So that's what we're going to look at, m2, not m1. That's one thing to remember. And number 2, give your answer in this. We must substitute this one as well because we're gonna need that. So now, okay, how do we do this? We have, let's start with on this part first. We start with dy over dt. So dy over dt, we differentiate this equation. Now, with that equation is the square root of 3 sine of 2t. So it will be okay, let me just write it here. Sine of 2t. So we will take the derivative of the inside function of sine of t. So that will be 2 square root of 3. The derivative of this whole thing, it will be cos 2t. Now that's your answer there. And then the dx over dt is given by, let's call this y equals to, and this part will be x equates to 4 cos squared of t. Now, this one is a little bit tricky because you just have to say, okay, start with 4. Now, you have two functions here. You can write this cos as cos of t squared. Now, you can note that this is a chain rule, so the derivative, it will be 2 cos of what? Of t. The derivative of the inside, it will be sine of t. Now, because we're deriving cos, the answer will be negative. So then we will be negative cos of t sine of t. It doesn't matter which one you start with. It just have to end up with the following. Now, to find the dy over dx, we have to do the following. We have to substitute, not substitute, we have to put this one, divide by that one. That's basically what I said you should do. So that's 2 square root of 3 cos of 2t divided by negative 4 cos of what? Of t sine of t. And don't try to be smart here and try to simplify this. It's going to burn you. So just take that t equals to pi over 6 and substitute it in there immediately as soon as you get, so that you can get your dy over dx, which is m1. And then you take that m1, you put it into to find m2. That's it. That's all you need to do. So you're going to substitute that, which is 2 square root of 3 cos of pi over 3. You can put it in your calculator. I'll just tell you the answer. Cos of pi over 6, sine of pi over 6. Pi over 6, I think, is 30 degrees. So you can just basically guess half times square root of 3. What does it give you? Square root of 3 divided by 2 as well. So that will be 4 at the bottom. The answer just becomes square root of 3 right here, which is negative square root of 3. I can actually work it out in my head. This one will be 60 degree. Cos of 60 degrees is the same as sine of 30, which is a half. So then that will be square root of 3 left at the top there. And then you have this whole part becomes a half. So half time it cancels out with that 2. That's why I just said square root of 3. And then here you will be be left with just check, square root of 3. I said you'll be square root of 3 divided by square root of 3 divided by 4. Because it will be square root of 3 divided by 2 times half divided by 2. Okay, and now that will be times that 4. Square root of 3, which is 60 degrees. 60 is same as sine of 30. Okay. Now you'll be left with, which is times by 4. Okay. Which is negative. Oh, I forgot one thing here. That's why it's not giving me the right answer. This part will become 8 because I'm going to multiply this 2 to the front. I just forgot when I put it there that I need to multiply by that 4 as well. So this becomes not 4 but 8. Okay. Now this becomes right. So I'm gonna get 2 square root of 3, and then this part which is negative, and then I'm gonna get a half as the final answer. And then this is m1, by the way. So m2, it will be over m1. Reason being, you're looking for the normal. Normal is always perpendicular to the m1. And then m1, m2, it will be just 2. And then now you need to find x and y coordinate. You find them by substituting back to the original parametric equation. So if you substitute them back, you're going to get an x coordinate of 3 and then a y coordinate of 3 over 2. Okay, let me just make sure that I didn't make a mistake here so that when I send the PDF, you don't have to copy the mistake. Okay, I hope I corrected all my mistakes. Okay. Now, you find the equation to the normal, so it's y equates to the gradient, which is m2. I'm just going to say m2 x minus x1, which is, this is x1, this is y1, and then it's plus y1. Now, I substitute in x minus 3 plus 3 over 2. Now, I have 2x minus 6 plus 3 over 2. Multiply everything by 2 since it's the one at the denominator. 2y equates to 4x minus 6 plus 3. And then this is 2y. And this is 4x minus 3. And now, with this information, wait. Something is not adding up here. Because this is giving me minus 3. Oh, that's what. I made a mistake there. When I multiply by 2, that doesn't remain as 6, it becomes 12. And then this becomes 9. And now I take everything to that side. It becomes 2y plus negative 4x plus 9. Okay, now I'm going to swap them so that x becomes positive, minus 2y minus 9 equates to 0. Sorry, it happens when you're moving too fast, you start doing the wrong things. So you've written out in this form, and then you got your answer. So yeah, you get all your 7 marks there from that. The space now it's unnecessary, so I'll just skip it. Okay, now with this question, we're gonna need to do the division. So you have the following, so which is 9x to the power of 3 plus 18. I'm gonna just write it a little bit smaller. 9x to the power of 3 plus 18x to the power of 2 plus 5x plus 4. And now we have 3x plus 2. Now, fortunately, I don't have a calculator, so I'm going to try to do it as best as I can. So I'm just going to find a factor that when I multiply with this number, it gives me that number, right? So that will be 3x to the power of 2. Now, I'm going to choose just a different color just to make it interesting. 3x to the power of 2. And then we're going to put here that factor, or the answer, sorry. So this one times this one and that one. I'm going to get the following answers split out. So it will be 9x to the power of 3. That should be your first answer. If this answer doesn't match, then you have a problem. So, okay, and then the second answer will be the second part, which is this part, and then it will be 6x squared. So that will be plus. And then what you do, you minus them, you get the bottom step. So when you minus them, you will get these guys cancel out, and then you get 0 there, and you should always get 0 there. And then it's 18 minus 6, and that will be 12. So that will be plus 12x squared. And then this one must be just brought down, so it's 5x. Now, you have a new situation here. You need to find a factor that will give you exactly this number. So then that number, when you multiply with what number? With this number. So then you basically, or you can just say 12 divided by that one gives you plus 4x. And then you get, that's it. So you can just say 12x squared divided by 3x. You get that answer. Then you just put it there. And then now from there onwards, you multiply it. You get 12x squared. And then you're going to say this one times that one, the same way you did with the first one. And then you're going to get plus 8x. Now you're going to do the same thing. You're going to minus them. This one should cancel that one. Great. If it doesn't, you've made a mistake. And then this one will be 5 minus 8. This one should have the same exponent, by the way, so that they're like terms. So this will be negative 3x. And then you bring this one down. So it will be plus 4. Now, you're going to take, again, this one, divide by that one. And now what you're going to get is negative 1. Okay, so with negative 1, you're not going to put negative 1 here, obviously. You're just going to put that thing in a negative form, 3x minus 2. That's it. And then you're going to say now you're going to minus them. So when you do minus them, what's going to happen is that these guys are going to cancel out, which is great. We want that. And then this one is going to be plus 6. So you're going to be left with 6 there. So that's your remainder. So this is called a remainder. So if you go here, they show that the remainder is 6. You have done it. Great. Now from there onwards, find the quotient, and then you can mention that the quotient is the thing that you got at the top here. That's the quotient. So that will be 3x squared plus 4x minus 4 minus 1. Okay. Now, the next question is quite interesting because let me tell you something. This part, we can factorize it in this form and its factor. So what we can do, we can write it in this form. So P of x is actually equates to 3x squared plus 4x minus 1 times 3x plus 2. And then it will be plus 6. Plus the remainder. Now, this is going to be important for the next question. Now, let's go back. We just say px, which is 2 and 0, Px is what? Is I think it's 3x squared plus 4x minus 1 times x, 3x plus 2, and then this will be plus 6. Now, this is where you guys lost marks because you forgot one thing. 3x plus 2. And now, what happens is that this part will cancel that part, but not entirely. There's one more left for this guy. So now, so in other words, we can just say the top part will cancel out the bottom one. But then for the first part, now you just have integral of 2 and 0 of 3x squared plus 4x minus 1. It's always the quotient itself, and then it will be plus 6 divided by the factor that was divided by the original expression, which is 3x plus 2. So if you don't know how to grasp this thing, you can just memorize it in this form. And now that's what you get. Now you integrate that part. Obviously, everyone knows how to do so. So it will be, if you don't know how to integrate this one, it's a big problem. So one of you I won't mention by name. So he likes to do integration and differentiation in the same step. And I'm like, oh my goodness. That's how you just throw away marks. So it will be 3x 2 plus 1. You take that answer, you divide by 2 plus 1. I'm doing it in 4 steps so that you don't complain that you don't understand that part. 1 plus 1 divided by 1 plus 1. And then it will be the derivative, the integral of a constant just turns into x. Or we just add x, we just multiply it by x. And then we have the following. This is reverse chain rule. So now we have the integral of the following. It's not reverse chain rule, sorry. It will be something different. So what we do, we can say, it is basically, in other words, let me do it in full because one of you don't attend classes. So if I just skip the steps, you guys, you still not understand this. So we have 2. We say u equates to 3x plus 2. Now we have 1 over u. Let's just say 6 over u, right? But now we can take, if we have integral of the following, I'm going to just do it as an indefinite integral. I'm going to take the 6 out. So this gives me 6 integral of 1 over u dx. Now I have a problem. I have a dx and I have a u there. Those two don't mix. Now I need to solve this one in such a way that I have du over dx from this guy. Okay. Now, what I'll do is that I'll just basically derive this one. So this will be du equates to 3 dx. The constant falls away. I'm deriving it, by the way. In other words, you used to derive it like this. You used to say du over dx equates to 3. Now, I multiply both sides by dx so that dx cancels out on this side, and that's why it's on this side. Now, I make dx the subject. Now it becomes du over 3 equates to dx. Now, okay, great. Now I have this step. Now I just need to substitute dx. So I have 6 integral of 1 over u, which is du, and then we just say divide by 3. Now the answer you get, it will be 2 integral of 1 over u du. So in other words, now we know that the integral of 1 over x dx is basically ln of x plus c. However, in this case, we have what? 2 ln of u plus c. Now, I don't need the plus c in this case. I can just put this part as it is. So what I'll do is that I'll just say it is 2 ln of the denominator, which is 3x plus 2. Now, how would you memorize this part if you had to memorize it? That's 0 there. I'm just going to move everything that I did here a little bit down. Okay, I put it down here as the explanation. Okay, now how would you do it? You just say the derivative of the denominator divide by the numerator, and then that's how you get this 2, and then you just basically put ln of everything. This only works if the denominator is made of a linear equation. Linear equation means the highest power of x is 1. That's it. Okay, now just understand that the highest power of x here is 1, and that will be the derivative. You don't do x squared because that's trig substitution. You don't do that. It's too advanced. Okay. Now, this part, it will be x to the power of 3 plus 2x to the power of 2 plus minus x. And then this will be plus 2 ln of 3x plus 2. 2 and 0. Now, it's going to substitute in. So you're going to get a beautiful answer of, let me just jump straight to the answer, which is going to be 14 plus ln of 16. So you will get it from there. Hopefully that makes sense. Don't want to spend too much time on that. Okay, and now this one. This one is where some of you did get it right. But yeah. So find the dy over dx as an expression. So it's that one. So you need to implement quotient rule. So I always say multiply the derivative as it is, the denominator plus 3. And the derivative of ln of x is basically the derivative of this part itself. So that will be 2 divided by its original, 2x plus 1. That's it. That's how you derive ln of x. So remember, these you treat them as two functions. And the derivative of u, it will be u prime equates to 2 over 2. Dude. 2x plus 1. And then v prime equates to 1. I mean, obviously v, you can see what v is. And then this will be minus 1 times ln of 2x plus 1 divided by, which is the denominator plus 3 squared. Now, it's always must be squared according to the formula. Okay, now that's the end of that part. You don't need to do anything further. They actually give you mark until that point, and that's it. You just leave it there. And then they say now, find the x-coordinate of m, show that the x-coordinate of m satisfies the equation of this one. So the x-coordinate of m is the maximum. So to get that, you need to take the derivative, which is basically x plus 3 divided by, which is 2 here, 2x plus 1. Then it's a minus ln of, did I say minus here? Yeah, good. Ln of 2x plus 1. And then this will be divided by x plus 3 squared. This will be equates to 0. So now we are trying to find the x-coordinate. They did tell us that x-coordinate m is the maximum point, so it's good. So we just need to substitute 0 in there. The derivative is 0, so we know that it is a maximum point. And then from there onwards, we know that the denominator will basically vanish, because we're going to say this guy times 0, and then the top part is going to times by 1, so it will still be, what do you call it? It will still remain. So, okay, now we have ln of 2x plus 1 equates to 0. Now, we're going to multiply both sides by 2x plus 1. Now, to get that, we just say, okay, we have we just need to make x the subject, sorry. What I'm going to do is that I need to make one of these guys x the subject. So I'm going to multiply both sides by that. So it will be 2x plus 3 minus ln of x, 2x. I can actually put it in front, sorry, which is 2x plus 1. And then this will be ln of 2x plus 1 equals to 0. So you can see that they actually make this guy x the subject. So how would you do that? And actually, let me just do this. I'm going to do it in a different way. I'm going to take this ln of x to the other side, which is 2x plus 3, 2x plus 1 equates to ln of 2x minus or plus 1. And now, what I'm going to do is that I'm going to trick this guy to go down below here, the ln of x. So I'm just going to swap it and just put it down there. So it will be 2x plus 1 equates to 2x plus 1 divided by ln of 2x plus 1. Now take this one to the other side, becomes negative 1. So you can see that this will eventually just become x, this is 3, x plus 3 divided by ln of 2x plus 1 minus 1 over 2. That's it. Now you have proved that. You get your 2 marks for free. And then they say, show by the calculation of the x-coordinate that m lies between that 2 thingy. So, okay, you have x equates to x minus 3, I think it's plus 3, divided by ln of 2x minus, why do I keep forgetting? Okay, it's plus. You can even copy it. If you couldn't get there, this is still a free mark question, 1 over 2. The first thing you do here is basically taking this x, that side, across the border. And then, or what you can do is that you can pretend as if you took everything to this side. Then it becomes 0. So it's x minus 3 divided by ln of 2x plus 1. Okay, and then this is plus 1 over 2. Okay, this result into 0. So what are you looking for? You're looking for, if you put 2.5 and then if you put 3.0, you're looking for sign change, right? Sign change. Think of it like this. If you have something that crosses the x-axis, if it's this side, it will be positive. If it be that side, it's negative. So if to show that by calculation, the x-coordinate of m lies between those things, you should have a sign change that, okay, yeah, the x-coordinate should lie between those 2 points. So you will see that if you substitute in, you'll get an answer of, if you substitute 2.5, so this is x equals to 2.5, and this is x equals to that one, you get an answer of 0, which is negative 0.07, and then here you'll get which is 0.4166. So that will be your answer there. I mean, here I'll round it off. The answer will be 0.0696. So then you can see, yes, there is a sign change. So that means that there exists a solution between the two there. That is true. So then you leave it at that. And then with this one, you're gonna put the iteration. So I'm just gonna call it x1 or xn minus 1. It will be basically now x plus 3 divided by ln of 2x plus 1. I don't have a calculator, so I can't really write down the solutions at this moment. I don't know where I left it. I think I left it in the car. And then you will obtain your answers as from, if you put x starting with x of 2.5, you get your answer as 2.57, and then you're gonna get it all the way when you put until 3, you're gonna get an answer of wait, I was lying now. Okay, wait. You're gonna start with, they tell us here, give us a okay, if you start with that as 1, you're gonna get your answer between the interval of 2.5685 and 2.5695. So that's the answer you're gonna get. So okay, yeah. So that's what you're gonna get. You remember, you must look until where the 4th significant figure doesn't change, but you must run it off to 6 significant figures. So okay, that's it there. And then we have sine of that one. So it will be 2 sine, I'm getting tired now, of cosec, which is basically 1 over sine of 2 theta. It doesn't have to be identical to that. So we're just basically going to solve this. So that will be 2 sine of theta, 1 over 2, and this will be sine theta cos theta. And this sign will cancel out with that sign, and that 2 will cancel out with that 2. We're left with 1 over cos theta. And 1 over cos theta give us what? Sec theta. That's the 2 marks that they ask you there. And then they say solve the equation of this part. To solve this equation, it's quite simple. What you're going to do firstly, you're going to convert this guy into sec. You have a 7 there. You didn't have a 7 there. You had a 2. So you can see the ratio degrees are the same. So you can basically just change the 7 into a 2 outside. So that would be tan squared theta, which is basically plus, I'm going to say 7 over 2 sine theta cosec 2 theta, and then this equates to 8. And then what we're going to do is that we're going to say it's tan squared theta plus 7 over 2, and this gives us sec, I think it is, yeah, sec, and then equates to 8. Now sec is 1 over cos, right? To make things easy for us, we just basically say, okay, we have 1 over cos theta, which is sine squared theta divided by cos squared theta. right? We can turn this tan squared theta into sec as well, which can make our life easy. So remember, if we do the following, I'm just going to write it here. Remember, sine squared theta plus cos squared theta equates to 1. If we want to turn this one into tan, so it will be tan divided by cos on both sides, cos squared, plus 1 equates to sec squared theta. Okay, now in other words, we could just basically say that tan is sec squared theta minus 1. So then we can put it in there. Sec squared theta minus 1 plus 7 over 2 sec theta minus 8 equals to 0. Now I can multiply everything by 2. So it will be 2 sec squared theta minus 2 plus 7 sec theta. And then this is minus 16. Okay. Now this will be 18. So that will be negative 18 equals to 0. This is 2 sec squared theta plus 7 sec theta. Now, from there onwards, you should get a beautiful answer. You're going to solve sec as you can say let k equates to sec theta. And then you solve a quadratic equation that looks like this. You're going to find the value of k and then just make sure that it lies between the interval of negative pi and pi. And then you're going to get our value of theta as plus or minus 0.952 and then plus or minus 1.76. The reason being the cos graph, you get the answer, the final answer is a cos graph, obviously. So then you're going to have a symmetrical shape. So I just drew it as a semicircle, but it's not a semicircle. So you know that if it crosses here and it crosses there, you have two answers that are plus or minus that are the same. So that's why you have a plus or minus theta. Okay, now that's your final answer there. And then to integrate this one, so most of you struggle with this one, but it's quite easy. You can see that here you have a ratio of the angles here is 1:2. Now you have the same thing here, which is 1:2, right? However, the 1:2 is in the form of half. Now you can say, okay, let half x be theta, and we can substitute that and say it is 8 sine squared. Oh, and this one is squared, by the way. So then we can basically say, okay, since that's the case, we can say, okay, we have theta cosec of what? 2 theta. And then this will be squared. That's what we have there. Now, what we can do is that we can re-put that part and we can put the 2 next to it. So that becomes 4, 2. Okay, I'm going to put it as 2 there. You'll see why. I put this one as 4, which comes out as 2, because it has to enter as squared. So I can't just, it will be times 2 squared sine theta cosec of 2 theta squared. So for this one to enter in here, it needs to be squared. So then I can say it's 2 not 4 but 2 here, sine theta cos sec 2 theta. Okay, now this part turns into 2 sec of theta, right? And now I know that theta is half x of square. I'm just simplifying that part. And then now the final answer I'm going to get is 2 sec theta, which is half of x. And now I'm going to integrate this part. That's the part I need to integrate. So I say 2 sec half of x, and then this gives me what? Of dx. So then what I need to do now, I say 2, I'll divide by the derivative of this part, which is basically a half. So then I'll say tan, the derivative of the outside is tan of half of x, and then it will be divided by half of x. So the answer I'm going to get, plus c, the answer I'm going to get, it is basically now this one, 2 divided by half is 4. So that will be 4 tan of that one, and then plus c, because it's an indefinite integral. So that's the end of the paper. Hope you guys enjoyed this video. I'll try to do it as fast as possible. But thank you.